This next question deals with correlation, and we have the hours a team practiced and the points they scored. This is a high school football coach collecting the data and trying to see if there's some sort of correlation between hours practiced and points scored. So the first thing we're going to do is we're going to check the conditions to see if we can actually do correlation. So the first condition would be that both variables are quantitative, and this is the quantitative variables condition. So what we notice here is that we have hours practiced and points scored. So right here we see that hours practiced and points scored are both quantitative variables. So to check the second condition, we need to check the straight enough condition. Now what I would do to check the straight enough condition is I would put a line through my data. So when we put a line through the data, we see that most of the points are well described by a straight line. Now we're only looking to see if the straight line goes through the data, and it doesn't have to go through all of it. But there isn't really a bend here. It's that the line would be straight. So with this in mind, we pass the straight enough condition here because a straight line does a good job of explaining the data. The third and final condition is no outliers. And if you say yes to this, you are saying yes, there are no outliers. One way to think of it that doesn't confuse people is to say, yes, we meet the condition that there are no outliers. Remember, we do not want there to be outliers. And what do we see right here? We see an outlier. So we actually have a problem. So we'd say no, we do not meet the condition of there being no outliers. And one thing you can do is you could circle that outlier. Circling the outlier would let the grader know that you noticed where the outlier is at. You could even mention the outlier. There is an outlier around 40 hours of practice and 20 points scored. This goes against the bivariate trend. And that'd be a great explanation right there. There is one outlier circled in my plot. That is a great explanation too. So make sure to remember the conditions for correlation are quantitative variables. Both variables are quantitative. Straight enough. A straight line well approximates the relationship in the data, and no outliers. There are no outliers. Finally, we have mention of what would happen if we remove that outlier. And we already talked about where it was at. It was at 40 hours practice and 20 points scored. So how would this change R? And going back and looking at our plot, we can see that this pulls out the ellipse. The tighter this is, the closer it is to positive or negative 1. And this would go towards positive 1 because it goes up. Since it goes in an upward direction, it's going towards positive 1. And since this pulls the density ellipse out, it's actually going to make this closer to 0. So if we were to remove that outlier, it would actually get stronger and R would get closer to positive 1. So removing that outlier in this instance would actually make it stronger. But watch out, because outliers can do anything. It's not always going to make it stronger to remove an outlier. We have a lot of instances where an outlier can make a very weak correlation strong. There's so many things that can happen with outliers. Outliers can make strong relationships weak relationships strong. They can make relationships positive or negative or 0. They can change anything. Always look at the specific instance of what would happen if you were to remove that point. And in our example here, we can see removing this point right here would actually tighten up the rest of these and make it more like a positive 1.